Sure. So today we'll start with the next topic, problems on thermodynamics. So this topic is based on physics. Okay, thermodynamics same chapter in the chemistry, but that is a chemical thermodynamics. This topic is based on physical thermodynamics. Okay, mostly the parameters are same. So today we'll see the fractions sums based on the thermodynamics. Okay, so there are only 7 sums. Easy. Let's start with the first one. So first sum says that a system releases 125 kilojoule of heat, while 104 kilojoule of work done is done on the system. We calculate the change in internal energy. So what are the given here? See, let's see the given. So what is the work done? Work is a 104 kilojoule. Now this work done on the system. So work done on the system. Okay, so that's why it's a negative. So if you know the concept, when you do the work on the system, it is a positive. So it is a negative. So एक system है, system के ऊपर आपने work किया, that means that work is negative. Okay. Then what is the next thing is given? That is how much energy is releases. Energy release हुआ, that is also negative. So it's a minus 125 kilojoule. Then what we need to find? We need to find the change in energy. So that is a delta U. That is a change in internal energy. No? So how to find the answer? So the solution is delta U is equal to mod of Q minus mod of W. So mod matlab even you write the negative value, it will become positive. So this is minus 125. Both units are same, no need to change anything. And this is minus 104. So mod matlab it will give the positive value 125 minus 104. So answer is how much? The answer is a 21 kilojoule. So how much change in the internal energy? Answer is a 21 kilojoule. Simple. It will be for 1 mark. It may become in the MCQ also or VSA, very short answer. So this is your first answer. Let's go to the second one. A gas contained in a cylinder fitted with a frictionless piston expand again a constant external pressure of 1 atmosphere. The pressure is 1 atmosphere and that will be converted into Pascal. And volume change from 5 liter to 10 liter. Volume increase. In doing so, it absorbs 400 joule thermal energy from its surrounding. Determine the change in internal energy. So we need to find the same parameter. Last minute change in energy find out. You have to see. So what is the pressure? Pressure is 1 atmosphere. So 1 atmosphere means how many Pascal? 1.013 into 5 Pascal. Then energy is absorbed. Meter cube 5 into 10 raised to minus 3 meter. What is the volume 2? So volume 2 is a 10 liter. So that is a 10 into 10 raised to minus 3 meter. Okay. And what we need to find? We need to find the change in energy. But for change in energy, what we require? Q and W. Q to pata hai, but what about W? So W diya nahi hai. That means we need to find the W. That is work done is required. So let's start with the answer. How to find W? Let's see. So what is a W? It is a P into delta V. P is a constant and there is a change in volume. So P kitna tha? 1.0. So before writing the value of P, we write V also. P is V2 minus V1. Sure. So what is the P? 1.015. Sorry, 15013 into 10 raised to 5. What is the volume? It's a 10 into 10 raised to minus 3 minus 5 into 10 raised to minus 3. So what is the answer? 1.013 into 10 raised to 5. 10 into 10 minus 5 is 5. 5 into 10 raised to minus 3. So if you solve this one, so your W is 506.5 joule. So this is the answer. You multiply here. This is simple. 10 raised to 5, 10 raised to minus 3, 10 raised to minus 2. So 10 raised to plus 2. You multiply the you will get the answer 5.06. And those 0 aage shift kiya, you will get this answer. Simple calculation you can do. So this is your work done. Work done to mil gaya. We know the Q also, so we can use that value. Let's see. So what is the delta U? It's a mod of Q minus mod of W. So both are value are positive, so no tension nahi. This is 400 minus 506.5. So the answer is minus 106.106.5 joule. So this is your delta E. So there is a change in internal energy. Is how much? Minus 106.5 joule. Okay. So that negative sign क्या indicate करता है that the internal energy decreases. जो internal energy decrease हुआ whenever there is a gas expand. Gas का expansion हुआ ना 5 liter to 10 liter. So the energy, internal energy get decrease. So पहले internal energy X था, now it's get decrease by 106.5 by the gas expansion. Okay. So second is also over. Let's see the third one. Third one is based on the diagram. Okay. Now, the system is taken to final state from initial in a hypothetical path as shown in figure. Calculate the work done each case. See, this is a graph of pressure versus volume. Pressure passes, it will start from 2 to 6. It is in terms of Pascal, 10⁵. And volume passes 2 to 6. And there is also one square, rectangle, we can say A to B, B to C, C to D, and A to D. So for each path, you need to find how much work done. Okay. So let's go for A to B. So first case is A to B. So we can say path EB. We can say path AB. So path AB, what is the work done? See, let's think about what is the work done? It's a pressure into volume. Okay. So pressure change होगा क्या? No, pressure is a constant. It's a 6 only. A to B में pressure is a constant, that is 6. 6 into 10⁵. And what about the volume? Volume change हो रहा है. देखो, this is from 2 to 6. The volume is changing. Okay. So we can write. See, work is always. So we can take this one as. So we can consider this as. So A to B, it's 2 minus 6. We can take 2 minus 6 into 10⁻³ because we have to find in terms of meter. So क्या होगा? This is 6 into 10⁵ into minus 4 into 10⁻². So answer is minus 24 into 10⁻². So it's how much? So ठीक है, इतना भी चलेगा. This answer is correct. 24 into 10⁻² joule. But we'll write the answer in terms of positive. Work done negative भी होता है. But this is a hypothetical concept, so we can write mod AW. Mod work done from A to B, it's a 24 into 10⁻². Because उन्होंने आंसर की में ये आंसर दिया positive, whether it is negative. So this answer is first one is 24 into 10⁻² joule. This is the first case. The second case, that is a path B to C. See, from B to C, pressure is changing 6 to 2, but volume is a constant. Volume is 6. So if I write the formula of WBC, pressure is changing, but volume is a constant. So it is 6 and again 6. So 6 minus 6 is 0. So volume अगर 0 change, volume में कुछ भी change नहीं. P into delta भी होता है. So this term is 0. So whole term will become 0. So here you can directly write 0. So WBC कितना होगा? That is 0. 0. You can write joule. Third one. So path C to D. So we can go for C to D. Now here the pressure is changing. So pressure कहाँ से चलेगा? देखो C to D. It's from pressure is same. Sorry, it's a 2 only. So 2 into 10⁵. And what about the volume? Volume is changing from 6 to 2. So 6 minus 2 into 10⁻⁻3. So what of 2 into 10⁻⁵ into 4 into 10⁻⁻3. So it's a 8 into 10⁻². So this is your WCD. So WCD is how much? 8 into 10⁻². Okay. Let's move for the last one. That is a D2A. So we can write path DA. We can write path DA. So for DA, WDA. See, volume is a constant, so there is no change in the volume. So if I write P delta V, so this quantity is 0, which change me, right? The volume is a 2 itself. So that's why this answer becomes 0. So we can write 0, 2. There is no change in volume. So there is no work done. Volume is कुछ change नहीं होगा. There is no work done. Gas का volume previously वही था. Now it's also same. So there is no change in the volume. So it's a 0. So this is also over. Let's see the next one. It's also based on diagram. See, it's look like a circle, but actually it's ellipse. The hypothetical thermodynamic cycle is shown in the figure. Calculate the work done in 25 seconds. See, so this is a center point. अब ये सर्कल है कि इलिप्स है देखते हैं. Actually it's ellipse. Okay, see, ये हाइट देखो कितना है? 1 to 11. मतलब ये हाइट 10 है. ये देखो, this is 2 to 6. मतलब ये 4. सी अगर ये सर्कल हुआ तो बोथ आर डायमीटर. यहाँ पे डायमीटर 10, यहाँ पे डायमीटर 4, मतलब इट्स नॉट अ सर्कल. तो क्या है? इट्स इलिप्स. सो दिस इज द मेजर एक्सिस दैट इज 2a and this is the minor axis that is 2. Okay, so we can draw here. This is as the major axis that is 2a and this is the minor axis that is 2. Okay, so we can write given figure represents ellipse. Okay, and for the ellipse, area enclosed by this figure is pi ab. So whenever there is an ellipse, area कितना enclosed होता है, area जो कितना covered होता है, pi ab. What is a? A is a semi major axis, and what is a b? B is a semi minor axis. But how to find a and b? See, a is equal to, see, a is how much? 1 to 11. No? It's a 1 to 11 and Pascal. So 11 minus 1 into 10 raised to 5. लेकिन ये किसका आंसर है? This is 2 है ना. So we require a. So we divide by 2. So this is 10 into 10 raised to 5 divided by 2. So what is your a? A is 5 into 10 raised to 5. Okay? And this is a Pascal. Then we need to find the b part. So let's go for the b. So what is a b? B is changing from 2 to 6. No? We can write 6 minus 2 into 10 raised to minus 3 divided by 2 because this is 2b. So what is the answer? The answer is 6 minus 2 is a 4. So 4 by 2 into 10 raised to minus 3. And that is a 2 into 10 raised to minus 3 but 2. So this is a b. So right now we know both the value a and b and we can just put in the area pi ab. Now we put करेंगे, we'll get the answer. Okay, sure. Let's put behind it. So area is how much? Area is a pi ab. Okay, so let's see. See why I'm finding the area. Let's see. So this area is pi into. So we can get pi as 3.142 into 5 into 10 raised to 5 into 2 into 10 raised to minus 3. So this is only 10 and it will become 10 raised to 6, 10 raised to minus 3. So what is the answer? So we multiply this one. So we'll get a 3.142 into 10 raised to plus 3. So this is a meter square area. It's not a meter square. Square SHO. Now what is the work done? See, in each cycle, एक cycle complete करने के बाद, this is the area. That means this much area you will acquire. That means that much work will done. इतना area acquired किया मतलब that much work will done. And how many 20 cycles are there? 25. So we can write work done is equal to 25 times A. If you covered one area, one cycle में एक area covered किया, that is a work done. If you are doing a 25 cycle, you have 25 times आपने area covered किया. And that is same amount will be go for the work done. So 25 into A. So 25 3.142 into 10 raised to 2. So if you multiply all the things, it will become 78.5 into 10 raised to 3. So this is your work. 78.5 into 10 raised to 3. Approximate error. So this is your joule. So how many work done? See, एक cycle किया तो that much area is covered. मतलब that much work done is completed by you. by that figure, and then for the 25 cycle to just multiply the area by 25. Okay, simple fun. Let's go for the next. The ideal gas is taken to the isothermal process. Isothermal मतलब क्या होता है? That is the delta U is internal energy से change in internal energy. So isothermal process है, and if it does 2000 joule of a work on its environment, how much heat is added to it? So let's see the given. See, उन्होंने क्या बोला है? That work done is how much? 200, 2000. So it's 2000. So this is the work done. And due to the isothermal process, the change in internal energy. So how much heat is absorbed? See, given ये था, तो find क्या करना है? Q. So how to find the Q? Let's see the solution. So delta U is equal to mod Q minus mod W. ये तो पता है. So what is your Q? Q is equal to delta U plus W. So this is 0 plus 2000. So what is your answer? Answer is 2000 itself. So what is it? Heat is added to the system. That is a 200. 200. Add 1. So that's a positive. Release हुआ तो negative होता. Okay. So Q is 2000 joule. खत्म. Simple था. Next is the efficiency of a Carnot cycle is 75 degrees. Simple here. So the efficiency of a Carnot cycle is given, and the temperature of the hot reservoir is 727 degrees Celsius. Then calculate the cold reservoir. See what is it given. So Carnot cycle efficiency मतलब this term is eta. This is 75 percentage. So percentage मतलब we can write 75 divided by 100, that is 0.75. Then temperature of the hot reservoir is TH. It is 727 plus 273. So it will become 1000 Kelvin. And wanted to क्या find out करना है? We need to find the temperature of the cold reservoir. तो सबको ये formula पता होना चाहिए. There are two formulas connected with this one. So solution. Actual formula of the efficiency is TH minus TC divided by TC. Hot reservoir का temperature minus cold reservoir temperature divided by cold reservoir. If you want to find the temperature of the cold reservoir, so if you modify this one, modify करने के बाद क्या आएगा? 1 minus eta TH, 1 minus efficiency to TH. So if I just put the values, so 1 minus 0.75 into 1000, so it becomes 0.25 into 1000. So this will become 250 Kelvin, 250 Kelvin. So this is of the cold reservoir. It is called cold reservoir. So what is the temperature of cold reservoir? 250 Kelvin. लेकिन केल्विन को अगर मुझे डिग्री सेल्सियस में कन्वर्ट करना है, so क्या होगा? TC is equal to 250 minus 273. Then we will get in the degree Celsius. So minus 23 degrees Celsius. So both answers are correct. In the Kelvin also, in the degree Celsius. So minus 23. Okay? Because cold, so negative में आएगा. Now let's go for the next one. That will be last. A Carnot refrigerator operated between 250 degree Kelvin and 300 degree Kelvin. Degree नहीं आता मोशन. We can just get calculate the coefficient of performance. Let's see the given. So 250 and 300. That means which one is a cold? This one is a cold reservoir. This one is a hot reservoir. So TC is how much? 250 Kelvin. And TH is how much? 300 Kelvin. And what we require, we need to find the coefficient of performance, मतलब K. So what is the formula of this one? The formula is simple. जो हमने efficiency में किया था, उसका totally reverse. मतलब K is equal to TC minus TH minus TC. इसका reciprocal लिया, तो it will become efficiency. उसका reciprocal लिया, तो it will be coefficient of performance. तो ये कितना है? 250. This is 250. This is 200. This is 300 minus 250. That is 250 divided by 50. This is 5. So coefficient of performance कितना है? That is 5. खत्म. This is last. So here we're done with the. Let me check once again. So here we're done with the thermodynamics. इतने substance. We can go through the solve example also. This also based on the same. And these are the exercise only. There are total 6 to 7 sums comes under the thermodynamics. Okay, so we'll stop here. Thank you so much.